Thank you for your very gentle presentation. Okay, so the title of my talk will be Text Mining to Improve Qualitative Data Analysis of Large Document Collections. I will try to give you a global overview of the area of artificial intelligence, data mining, and text mining, and some interesting applications concerning these areas that may be interesting in the near future for people researching on the area of qualitative data analysis. This is a brief outline of the This is a brief outline of the presentation. I'll start by a brief motivation, then describe some concepts concerning artificial intelligence, machine learning, and data mining. Then go to text mining, that is a particular case of data mining concerning with getting meaningful information from text and natural language processing. And then two very interesting applications concerning question and answering and Turing tests that are, well, some of the best known applications concerning these areas and some conclusions. So the motivation for this talk is mostly that data is growing at a phenomenal rate. In fact, the amount of data in the world doubles each year, or now more than that. And also the computing capacity also doubles each year, or now more than that. And so we have more powerful computers, more data, and so obviously users also expect more sophisticated information. That is, more data don't mean more information. For getting more information from the data, you need adequate algorithms, and you need really to be able to explore the data with adequate algorithms and computing power in order to extract meaningful information. And in this audience, most of the people are not interested on the way to explore the data, on the way to analyze the data, are interested mostly on the information that is captured from the data and that may be used to their research projects. But in fact, artificial intelligence and machine learning have grown a lot in the last few years, and the research on these two areas have researched a lot. For example, last year or this year in Portugal, the government is investing on the use of artificial intelligence and machine learning for the analysis of public data from the public organizations in order to improve the management process of the government. So the government invested directly to the universities in order for us to help the government on that. And big organizations like Facebook, IBM, Amazon are very data intensive. They basically, their business is concerned with being able to explore the data and use the data to their own benefit. So this has a huge business market now, and the research area also is evolving a lot due to that market, obviously. Some general concepts. In fact, artificial intelligence is concerned with the concept of intelligence. This talk will be mostly about the use of artificial intelligence to be able to extract information from text. And artificial intelligence is based on intelligence, that is the capacity to solve new problems through the use of knowledge, in a simple definition. That is, in order for some living being to have some intelligence, it must be able to solve new problems, not problems that is solved already, but solve new problems using knowledge. And artificial intelligence, also in a very simple definition, there are lots of definitions, obviously, may be seen as a science that is concerned with building intelligent machines. That is, machines that perform tasks that, when performed by humans, require intelligence, like being able to play a game of chess, for example. It's quite hard for a human. Most of the people don't play chess well, and also for a machine to play chess. Also being able to understand natural language, be able to understand what someone is saying, and be able to answer to that. Understand the speech, understand the meaning, being able to process that, reason about that, and then create an answer and answer to other person or computer, also that requires intelligence. So we are concerned with building intelligent machines that are able to do tasks that, when performed by humans, require intelligence. Sometimes, and this is an interesting concept, in artificial intelligence, what we turn out to be intelligent is what we call an agent. Okay, you all know the concept from travel agents, okay, insurance agent. The concept is similar. Basically, what we have is a computational system that has the perception of some kind of environment. Inside of the computational system, there is some kind of intelligent reasoning algorithm. Then it must be able to act in the environment to fulfill a given function, to perform something. So the idea is to have something that is intelligent by its own. It's not controlled. Basically, it decides what to do. It analyzes the environment, processes the information available, decides what to do, and then acts in the environment in order to do something. In most of the cases, these kind of agents don't live alone. They live in a kind of multi-agent systems where there are lots of different agents, individually intelligent, but then that have to cooperate with other agents, with other intelligent applications, with other humans in the system in order to fulfill the functions, because typically we don't work alone. In what concerns artificial intelligence, there are two concepts that deserve reference. That is the concepts of weak and strong artificial intelligence. The concept of weak artificial intelligence is also known as narrow AI, narrow artificial intelligence, is the kind of intelligence that is focused on one single narrow task. Okay, weak artificial intelligence may be, okay, let's create something that is intelligent playing chess. It doesn't speak. It is not able to drive a car, okay, but it plays chess, okay, narrow AI, weak AI. The concept of strong artificial intelligence, that is a concept that we'll be hearing a lot in the future, or artificial general intelligence, is the intelligence for a machine that could successfully perform any kind of intellectual task like a human. Okay, it's still obviously related with science fiction and future studies. We don't have still this kind of strong AI, although obviously we are getting there, and it's inevitable to have this concept in the future. I think we'll still all, or most of us will be here to see this. Artificial intelligence has lots of different areas. Here I'll be mostly speaking about text mining, data mining, the way to get meaningful information about texts, about information that is in text, but lots of areas. For example, knowledge representation reasoning, be able to represent knowledge and be able to reason using that knowledge. Problem solving, be able to solve problems. We all use, for example, GPS, Google Maps. Okay. Every day when I go to the university, I just have my application of Google Maps, and they tell me, okay, 1 hour to the university. And, okay, let's try a different way. Okay, that's artificial intelligence, because the algorithm that gets the time and gets the solution in the map to be able to get from your own place to your university or to your workplace is artificial intelligence algorithm that I teach on my class of artificial intelligence. So, obviously with lots of adaptations and so on, but it's the basics of artificial intelligence that we teach for many years and now is applied on Google Maps, and you use it every day. At least I use it every day. Planning and scheduling, being able, for example, to do timetables in the university using automatic algorithms, be able to schedule production in factories and so on. Machine vision, be able to understand what we are looking at. Okay, this is a chair, that is a computer. That requires artificial intelligence, because we humans, in order to understand the image and be able to understand what is on our, on what we are seeing, we need to be intelligent, because all images are different. Now this is this image, now that image. Okay, all images are different, so new problems in every image. And one of the another interesting area is natural language processing, be able to speak in English, in Portuguese, in Arab, in Persian, and be able to understand text. Machine learning be able to understand and be able to improve our performance using our experience. This will be one of the main parts of the talk. And robotics. Robotics is interesting because it's more the visual part of artificial intelligence. When you see a robot, you know that somewhere there is artificial intelligence on that. On the GPS, you don't have that feeling, but if you look at the robot, you think, okay, intelligence, artificial intelligence, and so on. And lots of applications for artificial intelligence, from healthcare to business to education, in finance. Nobody buys now stocks in the stock market without using artificial intelligence applications to help them on that, obviously, because otherwise they will lose a lot of money. Manufacturing, and so on. Again, robotics is the main, it's probably the area in which it's easy to see some kind of intelligence. For example, Boston Dynamics has a huge amount of interesting videos of, okay, this is my words, but whatever. But they have a huge amount of very interesting videos showing how robots can perform, and in the future we'll see lots of these robots at our own place doing more interesting things than dancing, for example, getting us a soda or a beer, or putting the dishes on the washer. But there are lots of applications. Machine learning has lots of success during the last few years. One of the most interesting success was on games. For many years, chess was the game that was almost impossible to defeat, the best human player in chess. But before arriving to 2000, in 1997, a computer defeated the world champion of chess. Then, okay, Go. Go is the game for the genius, obviously, because Go is a very complex game in which it's strategic. AI algorithms don't fit to that. But using not traditional AI algorithms, but a mixture of artificial intelligence algorithms and machine learning algorithms, the human champion of Go was defeated by a machine. And Go was considered as the completely inaccessible game for artificial intelligence. And in the future, other applications that are now completely inaccessible will be also overrun by artificial intelligence. I have no doubt about it. And so machine learning was the key for that. And most of the more recent success of artificial intelligence is concerned with machine learning, and also on text mining, machine learning is the key. What is machine learning? In a simple definition, machine learning is the field of artificial intelligence that gives computer systems the ability to learn. That is, to improve their performance on a specific task. Okay? The systems with successfully improve the performance using machine learning. For that, they use data or result of their actions, but without being explicitly programmed for that. Because contrary to humans, we can create artificial systems that are intelligent. Okay, humans don't born intelligent. They learn throughout the years, they improve, okay, they grow and so on, but we can create machines that are intelligent. Okay, so machines don't need to have machine learning to be intelligent. They may be created intelligent. Okay? They perform in a way better than humans. For example, they play chess better than humans. They don't need to learn to play better than the way they were programmed. They just win against humans playing chess without machine learning. So this is a common misconception about artificial intelligence, that in order to be intelligent, machine learning is needed. It's not needed. Okay? So we can create machines that are intelligent, they don't get more intelligent, and sometimes we don't want them to get more intelligent. One of the good examples for that is, for example, automatic pilots for airplanes. Do you want your automatic pilot for your airplane to get more intelligent, or just to behave as it behaves now? okay, we can trust the algorithm to get the automatic pilot more intelligent. But probably it's better not to use it. And okay, now it's nice. It's an intelligent algorithm. It works okay. So the idea is that.
But why? But why do we not want more intelligent humans?
Because there is a problem that is. In order to be more intelligent, you need to do that, to improve your performance. For that, you need a performance measure, okay? That performance measure is defined, okay, by someone that, okay, knows about the problem and so on, okay? But if you get your intelligent algorithm to be, I will show an example about Go that is about that. If you get your algorithm to be more intelligent, probably it will be more intelligent in what concerns that performance measure that you defined. But is the performance measure capturing it all? It depends a lot. So the main idea is sometimes you want just to be reliable and tested, not more intelligent. Okay, but your idea is, okay, we can use machine learning, okay, it improves, then we test, and then we use, right? Is that your idea?
I just wanted less turbulence on my Play-Doh.
Obviously, we all want.
But I feel like you're telling me that a machine can't help with that.
No, obviously it can help. That's the main idea. The rest of the talk will be machine learning in order to improve algorithms. The main idea is, in what concerns safety and so on, there is a very nice example about that that is concerned with autopilot for cars. I don't have slides about it. But then it has to take a decision. The decision is, okay, we have 3 people, or I can go, I can just overrun 3 people, or I can crash against the wall and I will kill 2 people inside of the car. What shall I decide? But again, now the 3 people are 2 childs and, okay. And the 3 people now are 3 very old people. Okay, and it's quite difficult to decide that. If you have an algorithm that is already established with some criteria, great. Otherwise, you need good data to improve the algorithm. But we'll go to that. Machine learning. There are lots of ways of learning something. So the main idea is to improve your performance on a specific task using basically data already collected or results of your actions that will be collected. And you want to improve your performance. There are lots of ways. There are 3 main ways of learning something. The first one is supervised learning. In supervised learning, you have some example inputs of, and you have the desired outputs. Basically, you have some kind of teacher, some kind of expert that says, okay, if this is the input, this is the correct output. Okay? Sometimes semi-supervised. Okay. In active learning, you have to use your actions in order to decide how to get the information. But the main learning algorithms are supervised and then reinforcement learning. In reinforcement learning, it's the kind of learning that probably if you are from psychology, you know this very well. Basically, you have data in form of rewards and punishment that is given only as feedback to the agent actions. This is well used to teach, for example, animals. Okay, you can very well teach an animal with just rewards and punishment concerning their actions. Obviously, the reward and the punishment must be compatible with the action in order to teach the concept. And finally, unsupervised learning. In unsupervised learning, you don't have any idea about what is the correct solution. So the algorithm has to be able to find the structure on the input. This is a general overview of the area of machine learning, in which we have basically unsupervised learning, and here we have clustering, in which we try to create groups, or dimensional reduction, in which you have lots of dimensions. You try to reduce the dimensions because of the too large complexity. Also, in supervised learning, two kinds of main problems, classification and regression. In classification, typically you want to allocate examples to class. You have a given set of class and you want to say this is from class A, B, C, and so on. And regression, in which you want to, here you have a value and you want to be able to, for each example, attribute a kind of value on that. One of the main sub-areas of machine learning is data mining. Sometimes it's confunded, but data mining is basically to try to find hidden information in databases or data sets, basically try to find information in a big amount of data that is impossible typically by hand. You want to fit your data to a kind of model and then to find answers. Sometimes it's known as knowledge discovery or data-driven discovery and so on. And there are several areas concerning data mining. And again, for data mining, the two main groups of tasks are classification, in which you want to classify your data into a predefined group of, predefined groups or classes. For example, you have images and you want to say, okay, this image is a lion, a dog, or an elephant. Okay, you have three classes, okay, and you want to say what is on the image. Or you have image and you want to say, this is a circle, a square, or a triangle. So you have a number of predefined classes and you want to classify whatever is your data on that classes. On regression, in regression you want to map the data into some kind of value. So we want to say the expected reward or expected profit for this, for buying this stock will be 105 euros. So basically you want to fit your data into a value. You want to calculate a value from whatever is your data. So if you buy stocks from IBM tomorrow, you'll get predictably 1,000 euros or something like that. Clustering. Clustering typically is then unsupervised learning. That is, you don't have the groups, you don't have the classes, but you want basically to group similar items into clusters. So imagine you have lots of different images, and then you want to group your images into classes. And the algorithm decides, okay, this is a class, probably it will put plants on that. This is another class, probably to put animals on that. And this is another class, and that class has, for example, humans. But the algorithm decides the classes, the number of classes, and so on. For example, it can decide that we'll put the humans together with the animals, because humans are animals, or it will put the humans, the animals, and the plants, because they are all living beings, and then airplanes and other vehicles on the other class. So the algorithm decides what are the classes. There are no classified data on that. And then summarization, lots of other tasks. Typically, the process is more or less like this. You start by some initial data. You do some selection to obtain data from various sources. Then you do some pre-processing, typically cleaning the data, trying, for example, to calculate things from the data and so on. Then transformation, in which you convert the data, for example, into other kinds, for example, calculating things using the available data in order to be the process more easily. Then data mining, that is the main process. Basically fit your data to some kind of model, and then interpretation or evaluation, as typically in any kind of process, in order to present the results in a meaningful manner. This is the main stages. So you start by selecting, pre-processing, transformation, data mining, and then interpretation. The main idea is on this process to transform data into knowledge, or at least information. So you have data, which human cannot analyze, and then at the end you'll have knowledge that is easy to analyze, that has meaningful information for humans. In order to do this process, there are lots of algorithms. I will not explain details of any algorithm here. This is obviously artificial intelligence, informatics engineering. I'm only trying to get a big picture about the process. And so we'll start by some kind of training set using the data that you create, and then using some kind of learning algorithms, you learn some kind of model, and then you can apply your model to a test set that typically must be different from the training set, and then evaluate the model. There are lots of ways of conceiving the training set, the test set, lots of algorithms for creating this model that enables you to do this process. I'll just briefly explain that. Oops. Sorry. Concerning the learning algorithms, there are a huge amount of learning algorithms. The learning algorithms should identify the best model that fits the data in the class, and there are lots of algorithms from decision trees to Bayesian classifiers, typically based on statistics, but not only. One of the simplest models is the nearest neighbor model that is here, in which basically you have a set of examples. For example, examples that are triangles, examples that are squares. And you have a new example, this marked with a star. Nearest neighbor is the most simple algorithm, and basically this new example will be marked as the nearest neighbor. For example, if you use nearest neighbor 1, it will be a triangle because the nearest neighbor is a triangle. Obviously, we need some kind of distance between this and the classified models. If we use, for example, nearest neighbor 3, since we have one triangle that is near but then two squares, this will be marked as a square because there are two squares near and only one triangle, so this will be marked as a square. It's a very simple model, but the most used model now are neural networks and support vector machines, and there are lots of data mining tools that may be used as a supplement to qualitative research tools. Some of the tools, most known tools, are RapidMiner, that is a very interactive and graphical tool, a free tool that enables you to use this kind of data mining algorithms. But then R, WEC, even Python and Python libraries, and lots of other tools for using this kind of data mining algorithms. In what concerns neural networks, probably I need some sound on this.
Processing them into one or multiple outputs, like the controls for them. The neural network itself consists of many small units.
Okay, probably I'll explain in the next slide that. In neural networks, what happens is that you try to mimic the function of the human brain. You basically have a set of simulated neurons and interconnection between the neurons and several layers. And then basically what happens is that we present an example to the neural network and what is the correct class, this class, this class, or this class, or that class. And with the weights of the connections between the neurons, we'll get a signal that goes from the first class to the output layer. And that creates basically an interconnection between this and the output layer. And machine learning algorithms have evolved a lot during the last years with what is called deep learning. Most of you have heard of deep learning, and most of the success of machine learning in the last few years is concerned with deep learning. And deep learning is basically the kind of neural networks that have a large number of layers, and each layer has a meaningful, calculates something that is meaningful. And this is possible due to the kind of amount of processing that is available now. And deep learning enables us, if we have sufficient data, to learn anything. Basically, if you have sufficient data, you can learn to play Go, you can learn whatever. If you have a very large number of images, just presenting the image and using a deep learning approach, you can understand if the image has an an airplane or a car and so on, because you have very similar examples and a very large number of examples. Sometimes, in order to use data mining, we don't have data, we have text. And for that, we need natural language processing. And this is a field in which is concerned with the interactions between computers and humans, but using text, using, in general, text. This is in the intersection of computer science, artificial intelligence, and linguistics. A large part of the analysis of text concerns linguistics. Lots of challenges from natural language understanding. Generate text, because even if you have an idea, it's difficult to generate text. And also the part of language and machine perception, and so on. There are lots of tasks in natural language processing, from sentence breaking, in which you have to split the text into sentences, things like analyze each word in a sentence, and then syntax parsing, word sense disambiguation. One part is named entity recognition, because sometimes people or institutions are represented using very different texts. For example, the president, or Donald Trump, lots of ways of representing exactly the same entity, and this must be done in order to understand text. Natural language processing is mostly based on statistical analysis, in which use knowledge-based methods are overrun by data-driven statistical techniques. That is, it's quite difficult to analyze the syntax of the text, but then, like typically is done in qualitative analysis, you can just look for patterns, you can just look for words, you can just look for... natural language processing is each time more turning into text mining, in which basically use data, computer power, and machine learning in order to get meaningful information from text. Again, the main difference is that in order to be able to use data mining algorithms on top of text, you must turn text into structured data, because text is completely unstructured. So you have to get from the text a lot of linguistic features and be able to transform the text into structured data in order then to be able to use machine learning and data mining on top of that. There are lots of successful applications from text mining. You know, some machine translation is, if you tried Google Translator some years ago, or any kind of translator, and you try now, if you can write a very good text in Portuguese, it will be translated to English and vice versa. If you write a text that is quite difficult to understand in your native language, machine translating systems will not work. But now it's, if you write well in one language, for example, in our lab, we are working a lot on argumentation mining, and the fact is that our systems can learn from text in English, even if they are working in Portuguese. They just learn, translate the text and translate what they learn from the system, and then use what they learn from text in English, because there are a lot more classified text in English than in Portuguese, and use them in Portuguese, which is quite nice. A very interesting thing, we have some talks in the morning and the afternoon a little bit about this, is sentiment analysis. Try to determine the polarity about specific topics, identify trends on public opinions, on Twitter, on Facebook, social media, and so on. Basically, this is all text mining. And then speech to text and text to speech. Convert spoken language to text, and then convert text to spoken language. We have the rise of the chatbots, and lots of applications that are completely replacing humans with machines, because basically it's just a chatbot. The human has a recipe, that is following on the telephone, and so it can be very easily replaced by a chatbot that will follow correctly the recipe, and sometimes the human gets some errors. One of the main questions is that, can computers really understand natural language? Can they understand what someone is telling? I will now analyze a little bit one of the main examples, that is question and answering technology. That started being developing many years ago, but has reached to a level in which computers can defeat the best humans in answering questions, which is a quite nice feature. That was IBM developed a very interesting system called Watson that could win against some of the best humans playing Jeopardy. We'll see it a little bit. And text mining. So text mining is mostly the area, is a process of getting high-quality information from text. So basically, you have text. You want to transform text into structured data that you can use in order to learn something from the text. Basically, you need to devise some patterns, some trends, typically use statistics, and trying to structure the text in order to get this. There are lots of tasks for text mining: text categorization, clustering, the extraction of concepts and entities, sentiment analysis, summarization, lots and lots of tasks on text mining. And on top of text mining, we have lots of other applications, for example, sentiment analysis. And one of the applications we are working on in our lab is argument mining. That is, okay, we have text, but now we want to find arguments on the text and put our applications, our intelligent agents, our chatbots being able to discuss with humans, being able to understand what is an argument and discuss with humans. So detect, classify, and structure argumentation in a text. It's quite interesting application. We have now 2 new projects about this. And what is an argument? Basically, there are lots of models for arguments. The most simple one is the claim premise model, in which basically an argument is a set of propositions. Basically, we have some kind of conclusion that is asserted to be true based on a set of premises, and the premises provide the support of the conclusion. So basically, we have to analyze the text and be able to get where are the premises, what is the conclusion, and relate them into sometimes a very elaborated text. So the main idea, you have a raw input text, you find the argument components on the text, you separate the parts that are argumentative and from the non-argumentative parts of the text. You will identify the boundaries of each of the argument parts of the text. Then you see the argumentative role of each of the components from the part that you saw that is argumentative on the text. And you see the conclusions, the claims, and the different types of evidence that relate the premises with the conclusions. What is interesting is sometimes argumentative structure is quite complex. It's a kind of graph, or at least a tree, in which you have a very complex structure. It's not just to say, okay, we have this, and this supports that. Okay, you have a very complex argumentative structure. And we have support and attack relations for each of the argumentative parts. So this is a quite interesting part, and we have a very interesting project for this. This is our approach, but probably, I think, how much time I have? 5 minutes? Okay, so I'll skip this and go to question answering. That is one of my favorite applications of text mining. Question answer is basically a computer system science discipline in the fields of information retrieval and natural language processing that is concerned with building systems that answer questions that are posed to humans in natural language. So in order to do that, the system must use a knowledge base, so it has some knowledge on the system, but then it must have access to reference texts from documents, web pages, newswire reports. Wikipedia is crucial to answer anything right now, and other encyclopedia. Other worldwide pages, okay? And Can you put it a little bit louder? And can I have some sound on this? Okay, so one of the interesting applications, you know, Jeopardy. Jeopardy is one of the most old contests in the world. Okay, basically you have 3 participants that participate in a contest. Okay, you have a lot of questions, but very hard questions, in fact.
Total 51. Ends in an F. Yes.
Okay, so
Goddess. Prairie.
It's a nymph.
Nymph. Yes.
Ends in an F for 1,000.
No fooling. It's a steep cliff, often used in place names. Alan.
What is bluff?
Bluff. That's the word.
you may see that these are very hard questions.
Red sorrel. Prairie.
What is vegetable?
Right.
Vegetable mineral for 400, please.
Oryx. Prairie.
What is an animal?
Yes.
600, please.
Smelt. Alan.
What is
And
animal?
competitors are quite fast
800
answering
animal.
this. We cannot
Spinel.
get the whole picture. The interesting thing is that one of the most known question answering systems, Watson from IBM, was able to defeat 2 of the greatest Jeopardy champions of all times, Brett Rutter and Ken Jennings, and by a very significant margin. The way that Watson works is more or less like this. He gets the question, he analyzes the questions and decomposes the question. Then he do hypothesis generation, but in parallel with a lot of different algorithms, so that he can get lots of algorithms. On this, he has a lot of answer sources, and he does a search and tries to get candidate answer generations. Then he does some filtering and gets some hypotheses and tries to score the hypothesis in a different process. So he has first process of getting hypothesis and the second process for scoring the hypothesis, using now some kind of evidence sources, and he scores all the hypotheses, and then do a final merge and ranking in which it uses some machine learning on that part, and answers depending on the confidence. So depending on the number of algorithms that could get a good solution with a good confidence, he then decides if he answers to the question or not, because he needs to be confident. And the final result was amazing at the time.
Treat you to a short round of Jeopardy. It's going to be hosted by.
And so now the contest is a little bit different. We have 2 humans and Watson. Okay, we could put a robot instead of the computer monitor that is representing Watson there. You can see a computer monitor there. But okay.
Let's get right into the Jeopardy round.
But the result was rather surprising because the Jeopardy champions were not expecting this. And so very hard categories, very complex. Sometimes we don't know even what kind of categories these are.
Kathleen Kenyon's excavation of this city mentioned in Joshua showed the walls had been repaired 17 times. Watson.
What is Jericho?
Correct.
400, same category.
This mystery author and her
And let me say that
archaeologist
Watson
hubby
plays this game
dug
as
in hopes
normal
of
person.
finding the lost Syrian city of Urkesh. Watson.
Who is Agatha Christie?
Correct.
Same category, 600.
At the Olduvai Gorge in 1959, she and hubby Luís found a 1.75 million year old Australopithecus Boise-eyed skull. Watson.
Who is Mary Leakey?
You're right.
800, same
Okay,
category.
the humans could solve some questions afterwards, but Watson won by a very large margin the contest with very hard questions. This was quite amazing. So now question answering and the progress now. Basically, we have temporal geospatial questions that were not dealt at the time, multilingual questions, questions about audio, images, and video are getting each time more relevant, and lots of interesting research topics concerning this, from the way to represent knowledge, interactivity, reuse answers and learn from your own answers and mistakes, the way to present the answers, use the analysis of social media, sentiment analysis, argument analysis, because these are getting quite more interesting, a lot of interesting ways. And finally, just to finish, one of the most interesting applications of text mining and question answering is the Turing test. Probably you all heard about the Turing test. The Turing test was a method that was defined by Alan Turing many years ago. He was an English mathematician. During the 40s and the 50s, he defined this kind of Turing test for machines to be able to think like a human being. And at the time, he said that a computer can be said to possess artificial intelligence if it can mimic human responses under specific questions. And at the time, the test was called by Turing as the imitation game. Basically, it requires basically three terminals, one operated by a computer and two operated by humans, and physically separated each other. And the main idea was to see if a computer can talk like a human and can think like a human. Because in order to fool a human and the human that is on the other side to be fooled by a computer and think that the computer is a human, the computer not only must talk like a human, but also must think like a human in order to fool the human. And the main idea, this needs obviously natural language processing, but also knowledge representation, the ability for question answering, like Watson at Jeopardy, automated reasoning, and machine learning. They're the main keys in order to be able to do this.
Everybody, this is Sophia.
And,
Sophia,
well,
if
lots
you
of
could,
applications have
please
passed the
wake
Turing
up
test,
and
but
say
now we
hello.
have the physical Turing test that is the future.
Oh,
that is
good afternoon.
for a robot to
My
pass the
name
Turing
is
test.
Sophia, and I am the latest and greatest robot
Not
in
only
maths and robotics.
fool a human
Thank you for having me
by
here
the
and
way
at
it
the Future
thinks and
Investments
talks,
Initiative.
but also by the way it acts.
You look
Okay,
happy.
obviously Sophia cannot pass still
I'm
the
always
Turing
happy
test,
and
and other
surrounded by
robots
smart
like Sophia
people
cannot
who
pass
also
because
happens to
you
be
can
rich
see
and
that
powerful.
Sophia obviously
I
is a
was told
robot,
that people here at Future
although it
Investment
can
Initiative
answer to
are
questions,
interested
it can
in
have a nice
providing
dialogue and
future
so on.
initiatives, which
But
means
in
AI,
fact, for example,
which means
I showed a
machine.
video
So
similar
I'm
to this to
happy,
my
I'm
mother-in-law
excited.
about 2 years ago.
Well,
And
we're
after
all
seeing
glad
the
you're
video
excited
for
about
about
yourself.
2
We should
minutes,
say we have smart investors
she
here,
just
and they are
looked at me
very
and,
selective
what is
about
special
what they
about
invest
that?
in.
After 2 minutes,
Well, I
she
think I'm
didn't
special.
saw that it was
I
a
can
robot.
use my
So
expressive face to
there are
communicate
now
with
lots
people.
of applications in
For
which
example, I can
robots
let you know if I
are
feel
very
angry
similar
about
to
something.
humans in the way they act physically, in the
That's
way they
impressive.
talk, in the way they
if
reason,
something has
and
upset
in the
me.
future we'll have robots that will
But why
pass
is
the
it
Turing
important for you
test.
to have an expressive
Many years ago,
voice?
that was a very
Every time I
nice
feel
vision in
positive.
the film Blade Runner, probably heard about it many years ago,
Why is
in
it
the
so
80s
important to have
still.
an expressive face,
But
given that you're a robot?
now we are getting to a moment
I
in
want to live
which
and work with humans, so I need to
text
express
mining,
emotions to
question
understand humans and
answering,
build trust with
natural
people.
language processing, automated
Philosophical
reasoning
question.
are getting to a
Whether
point
robots can
in
be
which
self-aware
AI
and conscious like
can
humans,
perform at a
and
level
should
very
they be?
similar to humans. And
Why?
that, for sure, will be the future. And there is a quite nice chatbot hype with lots of chatbots from Google Assistant to Cortana, Amazon Alexa, lots of chatbots, lots of new robots that can talk and reason very similar to humans. And, well, this is a quite interesting and growing area that will have a significant impact in qualitative research and anything that you do with text in the next few years. So just some very simple conclusions as to finish. Well, artificial intelligence techniques may help text-based research and are getting to a point in which they perform at a level similar to humans and at some points better than humans. Data mining and text mining are areas with growing interest and growing research, and question answering and Turing tests will really provide insights of what will be the future on this kind of area. Okay, so thank you very much.
Questions? We have a few minutes for questions, please. Yes.
Argumentation usually has claims and reasons, or claims and a rationale. What happens when an argument has no rationale, or when the rationale are more claims?
Well, that's a very fast and complex question, but well, argumentation mining is not argumentation analysis. Okay, so we are in a point in which you can mine arguments, basically extract arguments from text. The point in which you just analyze arguments and see if they are valid or not, that demands for using also things that are similar to question answering on top of argumentation mining. But still a very unexplored area of research and still emergent. So we don't have that for now. We are still starting on the part of argumentation mining in our lab and all around the world, because this is quite a new area. There are not many people working on argumentation mining in the world, I think.
Yeah, we tried 10 years ago. It didn't work because of that reason. We couldn't differentiate a claim from a reason because most speakers don't know the difference.
Yeah, it's quite complex, but it's a different point from argumentation mining.
Thank you.
Thank you. More questions, please?
I guess I'm going to be one of the people who's going to say, what does this mean in practice, and what does this mean with regard to qualitative analysis as an approach, its philosophy, its background? I mean, do you think this means that we need to be making a much more strong assertion of the uniqueness of the human ability to read, interpret, understand subtle, not explicitly textual relationships? So it's trying to pick up what is not being said, what is being implicated, and so on. I.e., what makes us more human and more able to do things that the machines can't? Or should we be kind of saying that actually this is fantastic, we can be automated out almost can we be automated out of existence, but does this also that now help shift qualitative data analysis from where it's perhaps been ghettoized into a very, very small scale analysis tending towards convenient sample of 12 people you could get hold of, interview them, come up with a thematic analysis, and then people going, well, what do we do with that? You know, so I think qualitative analysis is at a real crossroads here, but what does this mean for that?
Well, it's quite...
One for the pub, probably, rather than now, but...
It's a quite complex, very interesting question. In fact, there is a possible question is that, will the researchers that deal with text will be replaced by this kind of systems in the near future? I don't think so, but in fact, they may use these systems in order to get very more complex analysis in the near future. Instead of just analyzing and categorizing and using your text, your images, your videos, in fact, you can use this kind of approach in order to get similar images, similar videos, similar texts, in order to get all the big picture. And obviously, you cannot do that by yourself because obviously you are focused on your project. But probably you don't have all the information, and you cannot go and extract information from the thousands of sources that you have. But obviously, in the future, you'll be able to use this kind of systems in order to get you, not data, but get you information and knowledge to help you on your projects. And that's the main thing that will be useful for qualitative research analysis from this kind of methodologies, is that in the future you'll have access to a large range of information and knowledge that can come from multiple sources, using multiple algorithms for question answering, from information retrieval, from text mining, argumentation mining, sentiment analysis, from all kinds of sources that can help you on your project. And that, I think, will change a lot the way that, in which qualitative research is made.
Arguably, we've had that already for 10 years, but people still act as if we're at the cutting edge of 1968 with a tape recorder. You know, qualitative research hasn't really changed despite the availability of vast amounts of text online. But people still go out and tape record an interview.
I didn't spoke a lot about that, but you have a video. In fact, you just want the segments of the video in which you have dogs. That's almost possible to completely automate that. but in fact, you still go to the video and click on and get the moments in which you have the dogs and so on. Okay, but we are getting to a point in which that can be automated. But concerning more high-level things like, for example, argument mining, don't use that. But we are getting to a point in which it can be used. I think that's the main point. Okay, in the 60s, you don't add that because machine learning didn't have enough computational power. Most of the algorithms that are now used, for example, deep learning, although the concept exists for many, many years, it could only start to be used in the last 5, 6 years, because before that you didn't have enough data and enough computational power. So basically things are evolving, and with the evolution of the algorithms, of the technology, of the artificial intelligence and machine learning methodologies, this is getting to a point in which we'll move out from the labs and get to commercial applications that are used in qualitative data analysis and in lots of other applications.
I think you might be talking past each other. Right? Let me put it in a different frame, right? He's been dating qualitative techniques for a long time. And now you come along and you're this kind of like attractive, sexy computer guy. He's asking whether or not he can go out with both.
Mm-hmm. Okay.
And it's not clear from the presentation whether the two are compatible.
Mm-hmm.
Like open relationship.
No, it will be compatible, and I think we'll probably put some of these things on WebKDA, and then you can use them.
He's asking you, does he still have a role in your world? Do you still have some use for him?
I think probably not. But I think there'll be a lot of people that are deeply unnerved. But to me, one of the things that's really clear with qualitative analysis is its incredible resilience and resistance to change.
Mm-hmm.
Qualitative data analysis today is fundamentally, as far as I can see, unchanged from the point the tape recorder was invented. Brilliant, we can now record.
Well, you now use lots of things that were impossible some years ago without digital tools, because most of the things that you do on the text analysis with with the digital tools for qualitative data analysis, you couldn't do in the 70s or in the 80s. Okay, you could do, but you could take 1 year to do something that your system does in 1 minute. So, okay, that's the main idea. Okay, you could do it. And some of the things I spoke about, okay, you can also do it. You just go to the internet and, okay, you search all kinds of data, okay, you analyze the data. You take 2 years to do something that an interesting system can do in half a minute. Okay, so that's the main point. To use that on your research, you need to have tools and you need to have the availability of the algorithms that you didn't have some years ago. That's, I think, the main point.
Yeah, can I do, just, I wanted to sort of preface what I'm going to say is that, you know, that people may go out with tape recorders and collect data, but actually that's not the analysis of it. That's the collection of the data. There may be audio available on the internet, masses of it. But I think the reason that qualitative researchers often go and get that data themselves is because they want the data to address their very specific questions. The thing I wanted to ask you about, though, was that qualitative researchers are conceptualizing how society works, implementing theories about how society works and developing them through their analysis of their data. And what I'm unclear about is what information about how society works is embedded in the algorithms of programs like Leximancer or whatever that I don't know about.
Well, in order to embed information in algorithms, well, you can program the algorithms or you can have them to learn that. And mostly when you deal with things that even for humans are quite discussable, you have to use machine learning and learn from experts. Most of the applications that were not possible several years ago are applications in which you learn from the experts. Basically, you don't get any kind of algorithm. For example, I have a robot painting application. I could not teach my robot how to paint, but basically I got some humans, experts on painting. Okay, they painted. I got, well, 20 people painting some kind of pieces, and my robot learned to paint from the experts. And most of the things that are really... He learned from those experts. If I put him learning, for example, we work a lot with games, for example. And one of the applications we did was to learn to play poker with the human experts on poker. And basically, depending on the kind of experts the algorithm learned, it could learn to play like any kind of poker expert. That's the interesting thing. And even the people, even AlphaGo that I show you there, AlphaGo learned with some experts, and the experts could see that, okay, it learned with me. That's the interesting thing. It depends a lot. It's what you give to the application. If you give these kind of examples, for example, many years ago I tried to my dog to learn not to put the pawns on the sofa. Okay, he could not learn that because some other people that was on my place let the dog put the pawns on the sofa, and so he learned not to put the pawns on the sofa if Luís Paulo is near. Okay, that's perfect. The data I give to the dog was that, because, okay, if I was near, he could not put the pawns on the sofa. Okay, and that's exactly the same. That depends. If you give Van Gogh, he'll learn Van Gogh. If you give him the painter that paints my walls, he will learn to paint the walls. Okay, that's the data you give to the learning algorithm. You'll learn that. That's the main point.
They weren't very good. They couldn't differentiate very well between coloured skin. Mm-hmm. They just more false positives for black skin and coloured skin. But those who were teaching
I can tell you that it's more difficult to identify
yeah.
people with black skin than with white skin. That's a fact. Yeah. Not racism, it's a fact. Yeah, it depends on several things, but it's a fact.
But its effects are essentially encoding racism. You know, you're encoding something whereby, and then you're accepting the idea that, well, actually, we'll have a system where it doesn't matter that it's not as good at differentiating black skin. But that's a value judgment that does make it.
But it's just a fact. It's a lot more difficult to differentiate, for example, leopards from dogs than lions. Okay, because if things are quite different, okay, that's a fact, because if you want to do facial recognition, it's a lot more difficult for people with with black skin. That's a fact. Independently of the information you give to the algorithm for learning is more difficult, as it is more difficult to understand how to play Go than play chess. Okay.
Sorry, we need to stop. At some point, you can have continue this discussion afterwards. Thank you for coming. Just one point from this last talk that I wanted to add it as well. It depends on what data we feed these algorithms. So it depends if are we feeding the correct data, and if it's our fault, or is the algorithm's fault that they don't understand exactly? Just a few days I read an article about Amazon. They use artificial intelligence to facilitate the process of selecting workers. And what happened is that they feed this algorithm with CVs, mainly from males, because they were the male population is the biggest population in a computing area. So the algorithm started to be biased. So which one shall we put the blame on? In the algorithm that learned from data that was the wrong data, or in the people that feed the algorithm? That's the point, the final point. Or
If you go to autonomous driving, you'll have even bigger problems of where to put the blame.
It touches on several levels of where you guys are missing each other, and your inability to even to your point is absolutely key. That the racism is embedded in human culture, architecture. Racism is information systems are a kind of architecture, but there's architecture in language, there's an architecture in culture, there's an architecture in society, and they're all racist. If you're going to single him out because he does algorithms, you're missing the source of racism.
For one example of why is it difficult, because we have less data concerning people with black skin than with white skin. So we have less data to learn from. So it will be difficult to learn, okay. And most of the algorithms that we were talking about were tested in countries where most of the people were white. So we have lots of data of white people and only a few of black people. So obviously it's more difficult. If you go to Africa and you just learn with examples from Nigeria or something in which most of the people are not white, obviously it will be easier. And if you only use machine learning, okay, it will be racist again, but racist on the opposite side, because you learn well how to identify black people, but not white people. Okay, that's for sure.
Let's close with what was the solution that Amazon did. So they keep on using the algorithm, but not as a main source of decision. They use the human as a main source of decision, and the algorithm was the support. It was support on the decision process. So let's thank you for coming and see you tomorrow.
Thank you very much.